We are now pleased to have Jordan Sullivan from the Unitary Foundation with us. Welcome, Jordan. Thank you for being with us. How are you?
I'm doing great. Thanks for having me.
Okay. Would you mean if I read your background to the audience and give a summary of your presentation?
Please.
Okay. Jordan Sullivan Land's Quantum Compilation and the Unitary Foundation, dedicated to supporting public goods in quantum ecosystem. Jordan has done experimental and theoretical research in quantum computing at UC Berkeley and Fisk Quantum, a $7 billion valuation in 2025 as we are developer advocacy and product management at Amazon Bracket. The title of this talk is Building the Quantum Open Source Ecosystem, a View from Unitary Foundation. Session overview. The benefits of classic open source software are widely recognized and immense. A 2024 Harvard student estimate the total value of open source software at 8.8 trillion on the demand side. The Unitary Foundation takes on the realm of quantum open source technology as our mission to support and cultivate. This talk will provide an overview of the value proposition of open source quantum and outline the primary ways the Unitary Foundation has cultivated an ecosystem of over 5,000 quantum open source develops across more than 100 countries and support the development of over 100 new open source software libraries, resulting in more than 450 research papers. We now have the pleasure of giving the floor to Jordan to begin her talk.
Thank you very much for that introduction, Diana. Alrighty, I will go ahead and share my screen here. Okay. All right, are folks able to see this first slide?
Yes, we can see.
Perfect. Alrighty. Yeah, so as Diana said, I am Jordan Sullivan. I work at Unitary Foundation. I lead quantum compilation at the Unitary Foundation. And if you're asking what is Unitary Foundation, if you have not heard of it before, I'm going to tell you all about that in this talk, as well as some of the work that we do in the field of quantum computing. Okay, so first of all, our mission here. So Unitary Foundation is a nonprofit based in the U.S., but we also have people who work all around the world. We have people in Europe. We have folks in different parts of the States, and we really aim to create quantum technology that benefits the most people. You know, in the quantum ecosystem, there are lots of individual startups, lots of individual research groups. There are government grants. There's many different sources of funding and different types of people who are working on different problems in quantum. And we really, really aim at quantum open source to identify areas where otherwise these particular problems wouldn't really get solved. Like, they're not things that it's very profitable for companies to solve, and they're not things that are very likely to get worked on by like PhD students, just because, oh, well, maybe it's not so beneficial for the process of doing a PhD thesis, for instance. So I'm talking in very vague terms, but I'm going to get specific later on. So I just want to kind of set the stage a little bit. Like, why do we care about open source software? Well, there's a Harvard Business School review of the actual economic value of global open source software. And the estimate they came to is $4 billion invested in open source generates 8.8 trillion in value. So it's orders of magnitude benefit to the broad software ecosystem and all the different technologies that we use in our everyday life. To do this kind of investment, it's a really, really, really good return on investment if you are trying to do that. So the estimate is that it reduces the cost of software for companies just in that kind of narrow subset by 3.5 times. So specifically, we focus on open source in quantum computing, as everybody's here for Qiskit Fall Fest. So everyone is a fan of quantum, I imagine. So for quantum tech specifically, open source helps us to find valuable applications faster. It helps us grow the workforce and makes quantum tech more efficient. So there are so many technologies that have been developed in the classical world that are based on open source software. The Mac OS is based on Linux. The whole internet is based on protocols that have been open source from the very start. The World Wide Web and all sorts of technologies that make phones possible. A lot of these are just developed by volunteers, kind of doing it on their own time. And Unitary Foundation really wants to find sustainable ways of supporting that kind of work that doesn't always rely on needing people to have the ability to just work for free on projects. It's always great if people are able to do that, but not everybody has the same access to that kind of free time. So this is something that we focus on. So we have three main ways of doing this. First of all, and our longest running program is our micro grant program. So these are $3,000 of no strings attached money for projects in open source quantum tech. Now, these are mostly open source software projects, but we do also fund open source hardware projects at times too. For instance, Open Quantum Design, which is open source ion trap device that has been being worked on for several years now. And our second program is research and development. So we do our own research. We apply for grants for various different projects. Mainly at the moment, we're focused on benchmarking and compilation, and I lead the compilation part of our research. So we develop MITIC, which is for quantum error mitigation. It's got about 250K downloads at this. Actually, I think it's up to 300K. I should update the slide. And quite a few citations. I lead the development of the open source compiler for UCC. And Metric, which is for community benchmarking of quantum computers so that it's easier for everyone in the ecosystem to see what the current status is of the industry, whether that is application level benchmarks or the performance of actual hardware devices, things like that. So the third and very, very important element of Unitary Foundation is the community, which I hope all of you will join in the future or consider yourself a part of already. So we have actually over 5,000 people in our Discord. That's just discord.unityfoundation. If you want to search it up, we have so many different channels for different quantum open source software projects. There's journal clubs, there's a job board, quantum memes, whatever you might find yourself interested in. There's definitely, if you have a question about quantum, you're new to the field, there's always somebody who can jump in and help you out or connect you with the right resources. It's a really, really supportive community. Highly recommend joining. And we have yearly hackathons that we run. For instance, Unitary Hack, that's our big one that we run every year. I'll talk a little bit more about that later. We also have workshops, weekly developer calls, community calls, just like Qiskit has their office hours in Discord. We have lecture series, a weekly Quantum Wednesday. We have very cool papers that have come out and big speakers who come in and small speakers. We have a whole mix of different folks who share their work in the ecosystem. And then we also have in-person events like Unitary Con, and we had workshop this year, which is a workshop on error resilience in quantum computing. So there's a whole array of events, and we're always trying to come up with even more new and exciting ones. This year, we're going to be running a unitary design hackathon, which will be focused on design and visualization in quantum computing. Okay, so let's talk a little bit more about our microgrants. So for the cost of 3 US PhD students in microgrants, we have enabled 130 different quantum open source projects across 30 different countries. We have supported 400 plus maintainers and contributors. There's over 20K commits on Git. We've actually supported the development of 3 new startups and 1 nonprofit. So like we basically, for a $3,000 micro grant, in several of these cases, we have come up with basically the seed money for entire startups. And obviously like $3,000 is a very small number, regardless of the long-term amount that these companies may end up raising in capital or raising to develop their ideas into full-on companies. All starts with open source software. So on the right, you can just see a handful of different areas in which we have granted microgrants in the past. So if any of you on this call are interested in microgrants, you have an idea along these lines, highly encourage you to check out our microgrants on our website and consider applying. So just to give a little bit of a kind of scattered idea of the kinds of microgrants that we tend to award. We have this first one, a graphics workshop. So this is a particular software tool, and they applied for funding to attend and organize a workshop for this tool at a quantum conference. We had one application that was just for documentation on an existing toolkit. This is absolutely something we love to support. Then we have a quantum tomography library written in Julia. And then we have a much more research-focused project on Lie algebraic properties of quantum circuits. So there's a really wide array of types of projects that we can support, but we tend to look for projects that have the potential to have a really broad impact on the quantum ecosystem, especially, tools that there's just no other existing tools that do the thing yet, or educational focus, accessibility, improving things like documentation and tutorials, so all stuff like that. And then a couple of statistics over here. We have about 85% of our microgrants resulted in additional resources to the micrograntee. So going on, whether that is in a PhD program or a fellowship or an additional microgrant, or many of these people, quite a few people in our community have found that doing an open source project, applying for a microgrant, receiving a microgrant is basically the start of their career. So this is a really fantastic way to get into the ecosystem. As somebody who's worked in the field for about eight years now, I often get questions on how to get into the field. And honestly, this is my biggest piece of advice: start contributing to open source software, as I'm sure many of you have in the past. And when you've gained enough experience in doing that to feel confident, then you are able to, say, apply for a microgrant or apply for an internship or a job in the field. So then also 51% of all microgrants have also gone to historically underrepresented groups, which is awesome. So now I'm going to talk about Unitary Foundation Lab. So this is the research that we do internally. And I say internally, it's pretty much all open source. We do develop in public. We are very active on GitHub and Discord. So first off, benchmarking. Okay, why do we care about benchmarking? Well, quantum analysts definitely care about benchmarking. A lot of the VC world, any kind of business world is very, very interested in understanding the actual performance of these devices. But of course, scientists are also extremely interested in knowing where we're at in terms of the course of development of the field. So the difficulty is that a lot of the benchmarks that come out of different companies tend to paint their particular device in the most positive light possible, which makes perfect sense. However, it can make things a little bit difficult to tell. You're like, okay, well, this company is coming out with results saying that their device is the best. This one's saying that their device is the best. Are these the same benchmarks? How can we compare apples to apples? So basically, Metric is a independent, third-party, neutral platform for reporting benchmarks on existing algorithms, existing quantum devices to help everyone understand where the field is at a given time. And Metric Gym is actually where we go out and run those benchmarks on quantum hardware ourselves that we have gotten access to. So why should this be open sourced? Well, transparency, reproducibility, modifiability. We want people to be able to trust these benchmarks and not think that they are unfairly biased toward any one particular approach. And we want them to be reproducible. We want people to understand exactly what is being run. No like secret special sauce is being hidden in understanding how these things work. So there are, in the classical and kind of ML world, there are tools like MLPerf and papers with code, which make this reproducibility easier. So we want to bring that into quantum. So this is an example of what some of these benchmarks actually look like. And on the right is a plot of resource estimates for a variety of different applications. So on the left, there are these kind of like quantum supremacy or advantage experiments, these kind of boson sampling or random circuit sampling applications that are a little bit more contrived, whereas toward the right, you have these estimates for more useful applications in cryptography or finance, quantum simulation, that kind of thing. And so these are basically, each of these is like a paper, or in many cases, some papers may have multiple estimates. So we're pulling from many, many different sources to record all these on the same plot rather than allowing them all to kind of exist independently and not really be sure how to compare them. So yeah, we have about 1,600 benchmark results across 750 submissions, and so far we've run about 10 different hardware benchmarks for Metric Gym ourselves, and we are expanding that to run on more platforms, more quantum devices. And next up we have compilation, which is my area. And first of all, okay, like why is this important? Why is compilation an area that we care about? So power users who want to run on quantum devices really need a tool to run error mitigation that works on different hardware platforms and different software libraries. So many people, I'm sure here, use Qiskit, but there's plenty of other frameworks like Circ, like Ticket, that people use for different really use cases and for different applications, or just different kind of comfort levels, different languages, right? So we want this to be an easy process, and so that's one piece of it. And the other is that a lot of people in the quantum computing ecosystem, I think over the past couple of years, have sort of gotten this misconception about quantum error mitigation, that it's not going to be necessary once we have quantum error correction, like full-scale fault tolerance, but that is not really the case. And there was a recent paper that came out by John Preskill and one of his students that really makes this point pretty strongly. There are plenty of error mitigation techniques that do not have this exponentially bad scaling that I think has been become kind of well-known in the field. So tools like MITIC, I think, are going to stay useful in the longer term, or tools that come out of MITIC. So then for compilation in general, we have we want it to be more accessible for people who are developing quantum algorithms to be able to transfer those algorithms across different quantum devices without having to do a lot of legwork. And why should it be open sourced? Well, if we want quantum computation to be useful and accessible to more people, we're going to need really strong open source compilers. We don't want to be locked into each of the different platforms where all of the compilation is happening under the hood and you don't really understand how to improve it. The other really important piece is that if you open source, well, a whole variety of things, but if you open source compilation, you are actually able to make way better use of the breakthroughs that people make in the fields. If somebody's like, oh, I just came up with this really amazing way of rewriting Toffoli networks. I came up with this really great way of simplifying this kind of circuit that comes up in quantum. If we make it easier for them to implement that rewrite rule, then it becomes accessible for everyone to use, and other people can build on that tool and stack it together with other techniques to make quantum programs run more efficiently. So this is actually a slide of combining UCC and MITIC together, combining error mitigation with kind of more standard circuit level optimization. So if you actually do both of these things together, what you see here is that for this test case that we ran, it's a small quantum chemistry example, the closest we could get to the ideal was actually combining the two tools together. If we do the compilation and the error mitigation, it performs better than either of those things separately. So there's a real power in open sourcing these tools because you can combine them in ways that lead to emergent properties that are actually better than either thing could be independently. And as I mentioned earlier, we have our Unitary Foundation community. We have our Discord channel. We have a variety of these different existing quantum open source software packages that have weekly office hours, lots and lots of different open source projects that are very active in Discord. We have our quantum job board. We have our weekly sometimes there's plenty of software talk in all of the Discord channels, and often we invite members of our community to give seminars during our Quantum Wednesdays every week. Sometimes it is an external invited speaker, and sometimes it is somebody from our community, because there are really, really strong researchers who are part of the community and who develop really awesome work. We do have our yearly Unitary Con, which in previous years, this has been kind of a small, like invite-only conference for people who are micro-grantees and super active members of our community. But this year, we actually opened it up to anyone who wanted to attend. It was at the IEEE Quantum Week in Albuquerque this year, and it was a really great turnout for people who were interested in talking about quantum software. We also had workshop, which is a new format this year. This was this workshop on error resilience in quantum computing. And again, this is this idea of combining quantum error mitigation and correction and compilation into a whole tool chain that is designed to help mitigate and manage quantum errors that come up in real hardware. Then we have our quantum open source software survey that we do. Let me see if that's my next slide or if this one's, yeah, I'll show that one in a moment. We have our Unitary Hackathon every year, and this is definitely a big event for us. It goes over around a few weeks. And it's a different format than most other quantum hackathons in the field, in that it's kind of a bug bounty format. So in this latest year, we had over 100 maintainers involved, over 54 different quantum open source projects. And for each of those projects, basically the maintainers of the project go through their open issues and they select ones that are well scoped and are going to be reasonably accessible for a new person to get involved in. And then they'll select around, I think it's between 2 to 5 issues that they would like to put a cash bounty on. And so they assign whatever the value is that they would like for that issue. And then we have our Unitary Hack website where people who want to participate can look at the whole array of different quantum open source software projects that are available. And when the hackers are able to close those issues, complete the issues as stated, then they get paid. They just get paid in cash, and this is quite unusual for most hackathons are kind of like a volunteer basis thing, but this is a way of actually again making open source work sustainable, paying people for their work. And so this is an array of other statistics from this particular year. We had over 900 registrants who joined during the hackathon. There were 172 closed bounties, so closed GitHub issues where people got paid about 20,000 in money that was earned by hackers over the course of the time. And so it's a really great event. So we actually just released our quantum open source software survey for this year, or rather we just released the results. So we do this every year. I think it's been about 3 or 4 years that we've been running this hackathon, and the feedback we get from the community is very, very positive. A lot of people use the data in this survey. So we ask questions about what people's favorite frameworks are, what they're using, what tools they want, what they are able to do, what they want to be able to do. And it's all about quantum open source software, and all of the companies that develop that kind of software and the individuals and research groups that develop this kind of software find it quite helpful for understanding their user base and understanding the needs of the quantum ecosystem and the people who use and write quantum software. So if you're curious about any of that or demographics, there's a variety of information you can check out here. And this is another recent thing that we have launched this year. And I was just describing the bounties that we run for Unitary Hack. And because our mission is really to make quantum open source more accessible and more sustainable across the globe, really, we wanted to see if there was a way for us to extend this kind of bug bounty format to the rest of the year. The Unitary Hack is usually just a few weeks. So we partnered with a company called Merit Systems, and they have a platform that is designed to pay open source contributors. So you can get paid anywhere in the world, doesn't matter where you are. You just need a GitHub account, and they will basically allow you to get paid for your quantum open source work. And so if you're curious about how that can work or what opportunities there might be here, you can go ahead and scan this QR code to read our blog post about it. So specifically, the repos that we're kind of piloting this program for are UCC, which is for quantum compilation, and MITIC, which is quantum error mitigation. So definitely be sure to check that out. Just as kind of a rough estimate, on a monthly basis, we have available about like $250 to $500 per month in the UCC repo for implementing new quantum compiler passes. So if this is something that you're interested in, highly recommend checking that out. And then I will just say, many people ask us, okay, like who pays for all this? How does Unitary Foundation like exist as an organization? It's all of these people. It's all of these organizations. We have our core members who are mainly existing companies or people who are part of consortia. We have institutional sponsors. We have a lot of government grants. And we have other supporters from various companies, various individuals who support us. And then we have our UF community. We have a lot of research collaborators across different organizations. We have our quantum benchmark community. We have our Unitary Foundation community and advisory board. And so, as you can probably see, we have a lot of connections to a lot of different organizations, a lot of different groups. So if you are unsure of how to get connected, more plugged in the quantum industry or the field, highly recommend joining our Discord, asking around, contributing to some of our open source projects. It's a great way to get connected. And I will just end here with this is our team. It's very small. We are distributed. We have folks in France, in New York City, in Seattle, like myself, and Italy. And so it's quite a global team, and we are very happy to be able to do this kind of work for the benefit of the whole ecosystem. And that is all I have for today. So I will say thank you so much for listening. And it looks like we've got a number of questions in the chat. So I think we can move on to those.
Thank you, Jordan. Thank you for excellent talk. And we proceed with the questions.
Mhm.
Could you explain how the Unitary Foundation identifies which quantum open source project to support?
Mhm. Yeah, great question. So Um, the way that we kind of decide, so we have a microgrant advisory board that meets on a monthly basis, and these are people who are well established in the field. Some of them are former micrograntee recipients. Some of them are people who are working at companies in the field. Some of them are professors working at research groups, and then of course there's the Unitary Fund staff ourselves. And so when we actually review these microgrant applications, as I was kind of hinting at earlier, are really looking for projects which have the potential to affect a broad part of the ecosystem. So oftentimes we get applications that are basically like research projects, like PhD or master student research projects. And while like we think that's great, there are existing funding sources for that kind of thing. And what we really want to encourage and try to support are things that are not just going to be useful for like this one paper that somebody wants to write, but also actually like this is a toolkit that a whole field or corner of the field can use. And this person wants to develop, or this group wants to develop the software infrastructure to actually build that out, or they want to develop the documentation and tutorials and like user experience to make that accessible for more people. And then another thing that we look for is the awareness of other tools in the field. So if you're like, I want to create a software library for doing tensor network analysis, but you are not familiar with any of the other tools that are already in that field, for instance, like physics, then we might come back to you with feedback like, hey, have you thought about contributing this to this existing tool? Or have you thought about like maybe adding a module onto that? We would be much more likely to support like contributing to an existing tool than like starting kind of an independent project that does basically the same thing, but like with a little bit of a tweak. So those are also things that we like to encourage. And this is, yeah, if you're seeing my cat pop in and out, this is Kira. I don't know if she can be seen, but yeah.
Thank you, Jordan, and beautiful, beautiful cat. Yes. What are the biggest challenge in maintaining quality and sustainability in quantum open source software?
Mm, that's a very good question. It's a lifelong question. I think the greatest challenges to maintaining and sustaining um, that I would have to say, sometimes like the challenge is just that people have different capacity at different points in time, right? Like if somebody has a lot of time during their PhD to do a lot of work on a project, or maybe somebody is a student and they have a lot of time to dedicate to open source projects, but then maybe they get a full-time job and so they don't have so much time to dedicate. So sometimes the challenge can be making sure that somebody who has acquired a lot of like kind of practical knowledge in how a piece of software works is able to effectively like translate or transfer that knowledge to the next person who might be working on it. And so sometimes that comes in the form of like making sure that really good documentation is written. Sometimes it's about tutorials. Sometimes it is about if possible, like allowing that person to be accessible and continue being part of the community. And I think we're really grateful to have a lot of people who really do continue to be a part of our community even after they get full-time jobs in the field. So that definitely makes it a lot easier to maintain. At a certain point, it's funny, at the beginning of an open source project, you're kind of like begging people to contribute and be like, this is really important. Like, we should be working on this. And then when it kind of reaches a critical mass, then you're ending up with like so many people who are like, oh, I want to get involved, like I want to do this. And then maintainers are like, okay, like how do we triage and like help everybody to have the support that they need to do these sorts of projects. So it kind of changes depending on where you are in the life cycle of a project.
Thank you, Jordan. Another question: how do you balance supporting experimental, cutting edge project versus more stable, production ready libraries?
It's a great question. So it's going to kind of depend on how well resourced each of the projects is. So if we see a project like for instance, Piccolo, which is for quantum optimal control. They applied for a microgrant originally for the project itself to develop it from basically like a small kind of experimental idea into an actual library that could be broadly used in the field. They did that really successfully. And then they applied for another micro grant for actually like building out the documentation for this project, building out the tutorials, building out the ways that new people can actually get involved in it. So sometimes you are able, I think in the best case scenario, we're able to spot projects that have the potential to be broadly useful in the field and help to cultivate those projects through the stages of being kind of an experiment into being a well-maintained, more robust tool. So I think that's like the ideal scenario that we want to see.
Thank you, Jordan. Uh, what motivates you personally to work in the open source quantum ecosystem?
Hmm. That's a good question too. So I think personally, I really like being able to have a really broad view on what people are working on in this field. So previously, I worked at a couple of different companies. I've worked at Quantum, great people, brilliant folks. But it's very focused on kind of like internal development. When I first joined there, it was a fully stealth mode company, and so there was like very little that I could talk about publicly. And while like internally, it's awesome to be able to do like really, really groundbreaking work together. I really do enjoy getting a view of like, okay, well, there's like 12 people working on different versions of this problem or different approaches to this problem. And here are the different roadblocks that they're all hitting. Here are things that they all have in common. And I really enjoy that. And, any company that you work on, of course, it makes sense that you're going to be mainly focused on what the goals are for that particular company. What I really love about open source is, and specifically about Unitary Foundation, is being able to have a really, really broad view into what people are doing across so many different corners of the field that if I was, mainly just focused on one problem area, I wouldn't have that kind of view. So I find it very invigorating to talk to people who are like, okay, maybe their project has like 3 stars on GitHub, but it's like actually amazing. And then I can be like, oh, like, well, that's so brilliant. If we combine this with this other tool over here, then like you could get this amazing speed up if you wanted to run this kind of quantum application. And so I love being able to spot projects and kind of the potential in projects that otherwise I wouldn't have the occasion to encounter.
Thank you, Jordan. Uh, what are some common mistakes new developers make when contributing to quantum open source project?
These are really good questions, guys. Um, so common mistakes. I think that there are two, and they're kind of like opposite ends of a spectrum in a way. So on one hand, I would say like the mistake that people make is being too timid in terms of like not wanting to like bother the developers or the maintainers with wanting to contribute to something. So they might be feeling like they have to like ask permission for absolutely every step. Like, oh, is it okay if I comment here? Is it okay if I like work on this? Is it okay if I like open a PR on this? Like none of that is bad. But we generally, especially with the repos that I help to maintain, I really want to, my cat is meowing, she wants to go outside. I really try to maintain an ecosystem and like an environment that feels like friendly and welcoming to new people, so that they feel like, yeah, like this can be your repo, that this can be something that you work on, and you should feel like empowered to do that. So that's like one end of the spectrum is like maybe being a little bit too timid. The other end of the spectrum is like uh, kind of being a little bit too demanding on the maintainer's time. So everybody has different capacity again at different times, and that goes for even people who professionally are open source software maintainers. And so in on the other hand, some people will tend to maybe comment on an issue and be like assign me this, and it's like, okay, well, we don't really work that way. Like, if you want to work on it, you can do that, you can open a PR, etc. And then they might like start following up and being like, why haven't you responded to me yet? Like, come on. So there's kind of two ends of the spectrum there. So if you can, I would like try to end up like in a bit of a happy medium in the middle there. Like, definitely like feel empowered to like reach out to developers and maintainers and like ask like, hey, like, what would you recommend working on, or look for the like good first issue tag in repositories. But then also just like be patient with people have different amounts of time. And if it's been like a couple weeks and you still haven't heard back, like, yeah, like follow up. But if it's been like 3 days and you're like, why haven't you responded yet? Like that's a little bit too strong. Whereas like, waiting for somebody to like give you permission to like say hi, that's like, you don't need to do that. You can just say hi.
Thank you, Jordan. We have another questions. What are the most effective ways for Mexican teams to contribute to a large open source quantum projects while working remotely?
Mhm. Yeah, well, good news. Everybody at Unitary Foundation is also working remotely. So there's a really, really big kind of like remote work situation in many parts of the open source ecosystem. I would say like Mexican teams in specific. Um, there's actually a good number of projects that we have funded that are by Latin American folks. So there may be ways of connecting more easily if Spanish is your first language. There's a number of projects like that, like HHAT is one. And really, I mean, you could, I bet, I'm not actually sure if there's currently like a channel in Discord for specifically kind of like location-based groups, but for instance, you could join and start like a new Discord channel and be like, hey, like this is where we're trying to like get more Mexican teams involved in projects. And yeah, again, like feel free, like feel welcome to do that. And get involved in whatever projects you would like. Yeah.
Thank you, Jordan. Another question in the same way. How can Mexican startups or companies engage with the global quantum open source ecosystem and leverage tools developed by the Unitary Foundation?
Yeah. Yeah. So I think like the best way to leverage existing tools is to learn that they exist. So a lot of people, and I think especially in the startup world, tend to have this mindset of like, all right, we gotta like build it from scratch. We gotta hustle. Like we gotta like, do our grind. And like there's a lot of like kind of competition and like individualistic kind of energy that often exists in kind of the startup ecosystem. And like while sometimes like yeah, you can like create really great innovation, there's often like a lot of kind of like surveying the ecosystems like foundational steps that are skipped. So I would say if you want to get involved, if you already have an existing startup or if you're thinking about founding a startup, I would say um, really starting to understand, okay, what is the landscape of tools that already exist in this field, and how can I get involved in, the maintenance or development or roadmap, or how can I just use this tool in my own tools? And there's different open source licenses. So like just because you're developing open source software doesn't mean you can't make like a company out of it. You can't make money off of it. It just depends on the license. So yeah, understanding like different open source licenses, that's important as well. And really understanding how to be a good open source um, uh, like member of the open source community, basically, in order so that you're not like feeling like you're just like taking existing tools and using them to make a profit, but you're also like actively contributing to those communities and making the software ecosystem better by being there.
Thank you, Jordan. Have another question.
Mhm.
What advice would you give to Mexican researchers who want to initiate international collaboration in open source quantum software?
Mhm. Yeah. So uh, again, I think like the best way to get involved in open source software and initiate kind of international collaborations would be to, again, just like the easiest way is to honestly to join our Discord because you can see all of the different channels that people have open for existing open source software projects. You can ask questions like, hey, does anybody know if like there's people working on this type of project in like any existing places in Mexico? Maybe you can find collaborators that exist already. Maybe if you want to start international collaborations, you could ask me like, oh, okay, like who's working on these sorts of things in the US? Like what kind of possibilities are existing there? So yeah, you can ask questions. You can kind of see what projects people are working on already. You can join office hours for weekly that we have for a variety of weekly uh, open community calls.
Thank you, Jordan. And another question. Are there, are there particular areas of quantum computing, example, error correction, hardware integration, algorithms, where open source contributions are especially important?
Yeah. Um, well, I'm biased and I'll say compilation because that's where I work, but I do honestly think that it's a big important area. For one reason, there are a lot of different quantum hardware modalities that are out there right now. You have photonics, you have superconducting qubits, ion traps, neutral atoms, all sorts. And each of them have different kind of low-level operations that are available on those different devices. And in order to run like an algorithm that you're like, okay, I want to run like Grover's search or Shor's algorithm or something to translate from like CNOTs and Hadamards and Toffoli gates all the way down to like laser pulses that I'm shooting at this device. That requires different types of operations to translate from this top level kind of abstract algorithmic representation to the low level physics. And so it's really essential for people to be able to openly contribute, even if it's not, just something that's only beneficial for this one type of hardware. But there are intermediate layers that could be used by all of them. There are techniques that maybe you think they could only apply over here, but maybe you could also apply them over here. So I think open source is really, really crucial in compilation.
Thank you. Looking forward, what are the foundation priorities for the next 3 to 5 years in building the quantum ecosystem?
Yeah, I would say, our priorities are in compilation and benchmarking, right? But within compilation, it's really going to be, I think, a lot of this error resilience and dynamic control in quantum programs. So at the moment, most quantum compilers like Qiskit or Ticket or Circ have not built in a lot of like dynamic logic. And by that I mean, like, if you have a quantum circuit, like all of the qubits just go forward in time, and they have you measure them all at the end. Whereas more dynamic logic, which you need to do things like error correction, may have loops and conditional logic where you're like, okay, if this qubit is doing that, then you should make this correction on this other qubit. And not all compilers actually have the ability to represent that or the ability to actually compile with that in mind. So as we move into the regime of fault tolerance and the regime of quantum error correction, understanding how to do compilation on these big problems that include error mitigation and include error correction and understanding how to do that on different types of devices. Like, these are really, really wide open areas of research that definitely need a lot of contribution.
Thank you, Jordan. A last question in the same way. How do you see collaboration between quantum open source communities and large industry players evolving in the near future?
Yeah. So this is an interesting thing. Most of the large companies who are working in quantum, like IBM, like Amazon or Google, Microsoft, all have open source quantum software projects. Like IBM has the whole Qiskit ecosystem. You have Xanadu, they have their Penny Lane ecosystem. They have Google has Circ, Amazon has Bracket. All of these different existing open source tools are out there. However, I will say, and like, that's great. But again, like, it is kind of the same thing of like, each company has their own milestones, their own goals that they're trying to pursue. And often I would say that there's a little bit of a difference between kind of like truly like independent open source development and more of like a develop in public model. And I would say a lot of the and like having worked at some of these places myself, like, there is in some cases like a bit more of a focus on develop in public if you're at a company that is a maintainer of one of these packages, which again totally makes sense. But it's not necessarily that they're being driven by the users of the software. It's mostly being driven by whatever the goals of the company are, and they may take user feedback into account, but it might not be like their main kind of bottom line. So I would say I really want to encourage and challenge the maintainers of existing open source tools to be like more actively engaging the community of users in helping do roadmap planning. And it's not just from a sense of like, oh, that's the moral thing to do, but like, it's actually the useful thing to do. Like, it helps to understand like where the ecosystem is going, where some existing collaborations between existing tools can be, and sometimes that can be difficult for like intellectual property reasons. But If it comes from the users themselves, being like, hey, I want to be able to use this tool and plug it into that tool, then it's easier to kind of bring that to your own leadership and be like, okay, hey, maybe we should build an integration for this. So yeah, those are just a couple of examples.
Thank you, Jordan, and thank you for your time in that excellent talk. We hope to see you again in other events, and thank you.
Yep, thank you so much. My pleasure.
See you.
Thanks. Bye-bye.